As Jay explained in the previous lecture, this course should be taken concurrently or after the Suspended Bridge Construction course, BP-301. This course has new information explaining management techniques such as the critical path method and pull planning process. In addition, and most importantly, understanding the construction process is crucial to having an accurate quantity takeoff, which we will go over later in the course. For example, imagine you are in country and pick up a 12-meter length of rebar. In order to transport this piece of rebar to site, you bend it into approximately two 6-meter pieces to fit into the truck. When you arrive on site, there is no way to unbend the rebar, so you now cut the bend off and have two sections of 5 meters left over for use. Sorry about that. Now, for example, say we are bending AO2 sections, which according to bill of materials for the standard detail of an A6 anchor need to be 300 centimeters or 3 meters long. With our two lengths of 5-meter rebar sections, we can get only two 300 centimeter sections. 1 and 2. We go back to the beginning with a 12-meter bar. Theoretically, we could cut 4 sections of 300 centimeters to bend AO2. However, with the same amount of material, because of the construction process, and in this case, more of the procurement process, we are only getting a realistic 2 sections of AO2 from a 12-meter bar. Now, before we move on to the content, the latest update to this course includes 2 more learning objectives. First, we will learn to analyze the material systems of the suspended footbridge from a purely geometric perspective, allowing for the creation of a flexible quantity takeoff tool. What I mean by this is that instead of measuring all of our values in AutoCAD, we can formulate equations for various dimensions that change based on information input regarding your bridge details. This way, you can tie your quantity takeoff to your design calculations and collaborate with the design manager of your team to optimize material usage. As you follow these lectures, try and keep a spreadsheet open to do the calculations. Think about what numbers will change if you select different details. Second, you should understand the concept of empirical analysis and how this can be a useful tool for highly uncertain calculations. In country, managers use an empirical or evidence-based tool to calculate material needs based on previous years. We will explore using contingency factors to take into account this historical data and match these numbers.